This is a LabVIEW Beginner Lesson Series, which focuses on creating a heart rate monitor. This is lesson 2.1, where we create a simple hardware monitor, and this lesson we focus on collecting a larger sample size. So this is because the read VIs might not always give the sizes of samples we want, so we have to create something that gathers enough data so we get the sample size we want. This is because we want to filter and analyze the data later. It's much easier if you can control the sample size. We'll be creating something that stores the last X amount of data, where X is configurable by us. We can start by just making a copy of this. You could just use this lesson here, but for simplicity's sake, I'll just copy it. So this is lesson, we can delete all of this, 2-1, and it's called collecting a larger sample size. What we need to do is to make a VI which gathers the red data and collects it to a larger sample size. A sample size set by us. We'll just make this larger as we will make the functionality here. We'll keep this waveform. We'll start by renaming this to just a raw data. And then we'll make a copy of it, but we'll make it a little bit larger before we do. And then, boom, let's make this one a bit larger too. We call this one the raw collected data. So now we have two. And we can just put it to the side here. Boom, and we can move these things here. Make this stop a little bit bigger. Not necessary, but let's do it. And then move it here. Okay. So back at this one again, and here we have it. So we need this data to go through some sort of transformation and then become larger. We have a shift register here for this one, but this is more of the input data. We want some data which is just stored in this loop. So we'll add a shift register to save data. We create a constant here, and we'll place this one outside as the input. You can call it visible label, raw collected. That's a good name. So we need a way for this one to gather and be placed with this one. There's a couple of ways we can do this, and the easiest way is just to unbundle this one. But since it's a waveform rather than a cluster, we need to use the special ones here. So we'll just pin this one and then drag this one out. This is basically the unbundle, and this is the bundle. They're not clusters, but they're waveform because they were made for LabVIEW before clusters existed. Some people at LabVIEW said that they would probably be clusters if they would be invented now. So what we want to start with is to take the data points of the waveform out of them, like unbundle them. The options we have here to select is T0 is the start time, dt is delta time, so the sampling rate, and y is the waveform, the actual data points, and the attributes is something more complicated, which we will ignore. We'll take the waveform from here and from here, because we want them to be placed together. These are just simple arrays now. We'll just move this one away. And what we want is to build an array from this. So what we do is we take the waveform that already exists here. So what we want is to connect this one here and this one here. And we want to concatenate the inputs. By default, this makes a 2x2 array when you connect two 1D arrays in here. But what we want is just a longer 1D array. And by choosing concatenate input, it does this. We could just connect this thing up and call ourselves done by just connecting this one here, and then oops, the raw here, boom, boom. And this would work. It would now collect a larger sample size, and it would do so without a problem. It uses the old waveform here to collect the T0 and the delta T, and so this would work. But now we don't control the size. We just get an unlimited size, which would overrun the application at some point because we just collect it to all infinite time, or as long as the application runs. So what we need is a way to cut it here, to snip it, so that if it's over this size, we need it shorter. What we'll do is just make this a bit shorter here, like this. Let's just create a little bit more space. We need to go into array, and we need the delete from array, because we want to delete everything we don't want from the array. So this is the one we want to delete from. We always want to start at 0 here, because we want to throw away the older signal, not the newer. And what we also need to do, let's create a controller. Oh yeah, anyway, create a controller and then call that samples S. We can do this, which just means the unit is in seconds. And from this should choose the size. But how would we do that? To know how many samples we need to delete, we need to know how much time each sample takes, and that we get from the dt. What we want to do is to figure out how many samples there is in X amount of seconds. And to do this, we need to divide the sample in seconds we want with the delta t. So this one just takes in doubles. So what you can do is to get these conversion palettes. You don't need them, so I could connect this one directly to this one, and the red dot means you convert it. But I prefer to just change it here, because the red dots can indicate that sometimes it doesn't work, but LabVIEW does this automatically. But it's good to know, so you have more control. So I'll just say this becomes a double, this goes in here, we can move this there, and then we want it back to an I32 again. And then we'll convert it back into I32, and then that's the amount we need to subtract from the front of the array. So what we need to do then is to figure out how many elements is in the array by doing this, and then subtracting this amount from this. And then there you go. Now we will delete, we will figure out how many we have, we'll subtract this. So subtract that, so everything over that amount will be deleted. Let's say we want 10 seconds of data. And for simplicity, let's say this thing samples 10 times a second. That means we want 100 samples of data. So it starts here, and then it divides 10 by 0.1, as this is not in hertz. And we convert this, and then this will become 100 here. And then it reads the total size of the waveform. Now let's say this one reads 150, we want 100. That means there's 50 too many here. So we will delete the 50 first in the array, because it reads from left to right of the array, leaving only 100. We can test this now. What we'll do is just move this one here, and then write 10 seconds and press play. Well, we'll see now that it actually won't work, because we're using a chart here. I just copied this chart over here, and a chart only collects a certain amount of data. So what we want actually here is a graph. So we can just replace graph, and we'll select the waveform graph. And now we have a graph, and let's try again. Because the chart kind of collects the data and does some of the work for you, but only inside of the chart. and with the limits of the chart. But as you can see here, now we're collecting as much time as we want to. So let's say we want 20 seconds, and it collects more data. You see here, it just moves from one data point to another, and then here it goes to 20 seconds. And if we shorten it down, say press 5 seconds, it will automatically delete all the old data and keep the new one. This graph only shows the data we have stored, unlike the chart, which stores the data for us. We would need a way to gather data outside of the chart if we want to collect it, but there's also a limit amount of how much data it can collect, so this would be a much harder way to do it. So let's stop it and then compartmentalize this into a sub-VI. We want this to be an input, and we want this to be the output, and we also want this to be an input. So what we'll do is we'll cover everything, we'll gather it a little bit, pull it down, and cover everything we want inside of the sub-VI. And this is it. And we'll do the same thing, create a sub-VI, and here we have it. We can place it there, take this one a little bit closer, then open it. We'll save it, and we'll call it the acquisition and set waveform size. And then we can edit this one too, edit the icon, case close from last lesson. And we'll actually just do the same as we did with the other ones. Set. And then we'll use an abbreviation, waveform size. Ooh, that becomes too far down. Let's do another trick in the book, which is just to start the new one here, waveform, boom. So we can control the distance they are. So we have room for more. And there you go. We're in set waveform size. Okay. So we've done this. We can look in here, maybe clean it up a little bit. And another thing I like to do with these VIs is to get the names on the side. And you do this by holding control, pressing space, and without letting control go, you press T, and all of these go here. I just think that looks nicer. So it was holding control, pressing space, and then while holding control, pressing T. And let's test that it works. And we see it stops at 5 or just shy of 5 seconds here. And it goes to 5 seconds here. And we'll select it 5. We can change it to 10. We see that everything works as normal. We can just now control the size, which will be good for filtering. I'll just save it. That's it for this lesson of collecting a larger sample size. In the next lesson, we'll learn how to filter the signal, so we'll get a cleaner signal than this jagged signal we have here.